The James Webb Space Telescope has simply sent Earth a monstrous admonition, and it's drawing nearer. This warning comes from the exoplanet Proxima b. With each new picture sent back, additional inquiries emerge, leaving specialists frightened. Each description from this far-off planet makes us wonder more about the secrets of the universe. Growing inquiries are emerging about a potential hostile planet close to Earth. Might there be an adjoining outsider planet that has antagonistic goals? Might Proxima b ever represent a danger to our very existence? The subject of extraterrestrial life has captivated humankind for hundreds of years, but with current technology like the James Webb Space Telescope, it has become an inquiry we can investigate more fully than ever before. Yet the universe isn't making it easy to find answers. We continue to use our best tools, such as the James Webb Telescope, to catch glimpses of far-off planets and worlds, hoping to find clues that may point to life beyond Earth. However, let's be realistic. Every new picture and piece of information reminds us of how little we truly know. While these discoveries could be monumental, they also highlight the immensity and intricacy of the universe, leaving us with more questions than answers. Grasping a distant planet like Proxima b could rethink our place in the universe. For researchers in astronomy, this is exciting, but for the general population, it often feels like just another piece of space news. Far off, abstract, and at times overwhelming. These discoveries raise more questions than they answer, driving many to wonder how this affects life on Earth. Could Proxima b truly harbor life or even intelligent life that could one day present a threat to us? Regardless of the tremendous power of the James Webb Space Telescope, it can only show us so much. Sure, we've learned some unbelievable things, like the fact that we now have stunning new images of Proxima b, and we know that the universe is considerably bigger than we ever imagined. But still, what comes next? The viable implications of these revelations can feel as vast as the universe itself. Proxima b, discovered in 2013 due to its gravitational interaction with its star, was a significant scientific breakthrough for many researchers. Finding this exoplanet was like discovering a new large neighbor. Proxima b is just slightly bigger than Earth, and it orbits its star every 11.2 Earth days, making it an intriguing subject for further study. From a scientific perspective, the idea of a distant world so close to our own is thrilling. Yet for most people, it's difficult to connect with a place that is 25 light-years away. To put that into perspective, even the fastest spacecraft ever built would take tens of millennia to reach it. Imagine what it might be like to stand on Proxima b. A star, Proxima Centauri, would appear as a dim red light in the sky, much cooler and darker than our sun. Proxima b orbits so rapidly that a year there lasts just a little over 7 Earth days. One side of the planet always faces the star, meaning it is permanently exposed to light, while the opposite side is covered in eternal night. It seems like something out of a science fiction novel, but the reality would be far harsher. On the bright side of Proxima b, any water would probably boil into steam due to constant exposure to heat. On the dark side, however, water would freeze into solid ice. The planet's star, Proxima Centauri, is also not a calm and steady neighbor like our sun. It throws out dangerous flares and intense radiation, making the surface of Proxima be a hazardous place for life as we know it. This isn't the kind of neighborhood where humans would want to camp out. Interest in finding life beyond Earth peaked in late 2020 when scientists detected a rare signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had a unique frequency of 982.551 MHz, which grabbed everyone's attention. Such a signal could, in theory, be a sign of advanced technology. However, it is far too early to draw any conclusions. More recently, the James Webb Space Telescope has sparked even more excitement by suggesting that Proxima b could have water vapor in its atmosphere. Water, as we know, is a crucial element for life, and its presence could be a game changer. To better understand how much water is present on Proxima b, scientists are using advanced techniques like spectroscopy. This method allows them to detect the gases that surround the planet, acting as a cutting-edge investigative tool. By studying the planet's light spectrum, researchers can identify specific gases such as oxygen, methane, and carbon dioxide, which are all essential for life. Atmospheric modeling is another key strategy. By creating virtual simulations of Proxima's climate, scientists can make rough estimates about its conditions. These models serve a similar purpose to how paleontologists use dinosaur fossils to predict what ancient creatures might have looked like. However, the more we learn about Proxima B's atmosphere, the more we are reminded of the remarkable diversity of life that exists here on Earth. Extremophiles, for example, are tiny organisms that can survive in extreme conditions, boiling hot springs, acidic lakes, and the freezing cold of Antarctica. These hardy creatures show that life can adapt and thrive in conditions once thought impossible. Could life on Proxima b be just as resilient? The search for life on Proxima b presents enormous challenges, not only in terms of space travel but also in proving that life could exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere may not offer much protection. Additionally, the distances involved are vast, meaning new kinds of propulsion systems are needed to make space travel to Proxima b feasible. Ideas like solar sails, particle drives, and even more theoretical concepts like warp drives offer exciting possibilities for future exploration. However, these technologies are still in their infancy and require extensive research before they can be used in real missions. While dreaming about future space travel is thrilling, we need to remain realistic. Finding life on Proxima b is fraught with technological and scientific challenges. Only by advancing our technology and expanding our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima b. This pursuit isn't just about satisfying curiosity. It's about pushing the boundaries of human achievement. Might we one day set foot on Proxima b or even make contact with life there? As we contemplate the long journey to Proxima Centauri and the potential of finding aliens, no longer does it feel bound to the realm of science fiction. Instead, it seems like a real, tangible possibility. This fascinating shift from a far-off dream to a scientific endeavor has attracted serious attention from cutting-edge organizations like Breakthrough Initiatives. These groups are committing tremendous resources to transform what would traditionally be an incomprehensibly long journey, one that could take several millennia using today's technology, into a mission achievable within decades. The goal of reaching another star system within a human lifetime has sparked innovation and optimism among mainstream scientists. However, these lofty aspirations are quickly tempered by the stark realities of our current technological limitations. Despite remarkable progress in space exploration, traveling to Proxima Centauri, even at just 4.2 light-years away, still presents enormous challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey feasible in any reasonable time frame. Breakthrough Starshot, one of the most ambitious projects envisioned, aims to use powerful laser-driven sails to propel small spacecraft to speeds of up to 20% the speed of light. While this concept shows promise, it is still in the experimental stage and faces numerous technical and logistical hurdles. For example, it must overcome the dangers posed by space debris and ensure reliable communication over vast distances. The dream of reaching Proxima Centauri and possibly discovering alien life is closer to reality than ever before, but it remains grounded by the constraints of modern technology. Accelerating a spacecraft to near the speed of light with today's tools feels nearly impossible, like trying to solve a difficult puzzle in the dark. Even bold projects like Starshot, which aims to shoot a spacecraft toward Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere causes disturbances for the lasers, making it difficult for space exploration tools to work with the precision needed. One proposed solution is the use of adaptive optics, smaller lasers on satellites that constantly monitor and adjust for atmospheric disruptions. This system would help powerful ground-based lasers remain focused on the spacecraft as it travels through space. However, the laser propulsion method requires a massive amount of energy, equivalent to the total energy consumed by the entire United States, and it would only work for a short time. Imagine setting up 100 million lasers over a vast area just to push a tiny spacecraft, only 33 feet wide, to 20% of the speed of light. At this speed, the spacecraft would still take 22 years to reach the Alpha Centauri system, a time span longer than many people's lifetimes. But the challenge of reaching Alpha Centauri isn't solely about overcoming technical obstacles. There are natural barriers as well. The gravity of the sun, the presence of space debris, and the sheer vastness of the distance involved all pose significant risks. Even communicating with a spacecraft on course for Proxima b would require sending messages through time. It would take about 4 years for a signal to reach it from Earth. Despite these overwhelming challenges, the desire to explore other star systems continues to grow. It is driven by humanity's deep yearning for discovery and exploration, rather than practical necessity. Even ambitious endeavors like Starshot, which aims to send a spacecraft toward Alpha Centauri using lasers, face many practical hurdles. However, overcoming these issues could revolutionize space exploration. Still, the potential risks involved, such as communication delays and natural hazards, require thorough preparation. Despite the difficulties, many scientists believe the rewards far outweigh the risks. Finding life on Proxima b or another distant exoplanet continues to captivate minds around the world. Discovering life on Proxima b, or even just understanding this distant planet better, could change everything. The discovery of life, or even the potential for life, on Proxima b would be a game-changer for humanity's understanding of the universe. For centuries, we have looked up at the stars, wondering if we are alone. Now, with advanced telescopes and space missions, we are getting closer to answering that age-old question. Proxima b, with its proximity to Earth and potential for harboring water, stands as a prime candidate in this search. The idea that there could be life, intelligent or microbial, beyond Earth would have profound implications for science, philosophy, and even our place in the cosmos. If life is found on Proxima b, it could revolutionize our understanding of biology and the conditions necessary for life to thrive. Would extraterrestrial life follow similar biochemical processes to life on Earth? Or could it exist in completely different forms, possibly even in conditions once thought to be inhospitable? The discovery of alien life would fundamentally challenge many of the assumptions about biology that we hold today. For instance, extremophiles on Earth, organisms that live in conditions such as deep-sea vents, acidic lakes, or polar ice caps, have already expanded our definition of what constitutes a habitable environment. If Proxima b, with its extreme temperature fluctuations and exposure to stellar flares, does host life, it could further push the boundaries of what we understand as livable. Beyond the scientific implications, the discovery of life on another planet would have a deep philosophical impact on humanity. It would force us to rethink our place in the universe. No longer would we be the only known intelligent beings, and this realization could unite humanity in ways that transcends national borders, religious differences, and cultural divides. The search for life beyond Earth might be one of the few common goals that could unite people across the globe, leading to international cooperation on a scale not yet seen. However, the discovery of life on Proxima b or another exoplanet might also pose ethical questions. If we were to find intelligent life, what responsibility would we have towards it? Should we attempt to communicate, or would we run the risk of harming these alien beings by disrupting their environment? Could they even understand our signals, or would their concept of communication be so alien that it would be impossible for us to make contact? And if we did make contact, what might it mean for us as a species, both socially and politically? On a more practical level, such a discovery would push the boundaries of our space exploration efforts. We would need to develop new technologies not only to visit distant worlds like Proxima b, but also to communicate with potential extraterrestrial civilizations. This would involve overcoming significant hurdles in spacecraft propulsion, radiation shielding, and life support systems. Traveling to a place so far away is still a dream, but technological advancements, like the development of laser propulsion systems or even faster-than-light travel, might bring this dream within reach. In the meantime, we will continue to study Proxima b and other exoplanets using the most advanced telescopes and space missions available. The James Webb Space Telescope is already providing us with more data than ever before, offering unprecedented views of distant worlds and their atmospheres. As the telescope collects more information about the composition and potential habitability of planets like Proxima b, we will continue to refine our models of how planets form and evolve, and perhaps how life might arise elsewhere in the universe. If there's one thing we've learned from the search for extraterrestrial life, it's that the universe is full of surprises. Each new discovery, whether it's a new exoplanet or a strange signal from a distant star system, reminds us that we have only begun to scratch the surface of understanding our place in the cosmos. The questions keep coming, and with each answer, more arise. Are we alone? Are there other intelligent civilizations out there? What is the future of humanity in the vast, uncharted expanse of space? Only time and continued exploration will tell. The potential for new discoveries is exciting, and while the challenges remain daunting, they are not insurmountable. The journey to Proxima b, whether through unmanned probes or future human missions, might take decades or even centuries. But the very pursuit of this knowledge will push the boundaries of technology, imagination, and human spirit. As we push forward in our quest to explore the universe, the possibility of discovering life on Proxima b or other exoplanets will remain a driving force behind our exploration efforts. It may take generations, but the pursuit of knowledge and discovery is a journey worth taking, for it could change everything we know about life, the universe, and our place within it. In the end, Proxima b might be just the first step in humanity's broader journey to explore the stars. Whether we find life or just learn more about the conditions that make life possible, these efforts will shape the future of space exploration. And perhaps one day we'll find ourselves not just sending probes, but sending people to far-flung exoplanets, an extension of our curiosity and drive to explore not just our own planet, but the entire universe. So as we continue to look to the stars, Proxima b remains a beacon, shining a light on the vast possibilities of the universe and urging us to reach beyond what we thought was possible. The journey to understand our universe is only just beginning, and with each new discovery, we take one more step toward answering the greatest question of all. Are we truly alone?